Yeah. So, hello everyone. I think it will be a surprising finish of the day. This is kind of different topic that you're usually covering here. It's not would be about web data extraction, but more about extraction from documents. And it will be kind of interesting topic about financial documents. So today, my goal is to show how we can move from messy user documents into reliable and operational framework that supports income verification. So I hope it would be interesting and you will take something that will be useful in your own projects. So let's start talking about a chaotic world of income verification. What is income verification? I guess that everybody in this room are pretty familiar with this process, but it's actually confirming an applicant's income. It is used by lenders, landlords, agencies, and all of them require reliable data. It can be done with different workflows, like directly contacting HR department or through applicant-submitted documents, through payroll providers. Even IRS has its own system. All of these flows have different coverage, costs, robustness, and amount of manual work needed. But today I will focus specifically on income verification through applicant-submitted documents. So in this process, applicants provide everything from PDFs and scanned documents to ordinary photos as a proof of income. And this flow is pretty common because it has highest coverage of employers, and also it's really straightforward to implement. Originally, verification via documents is highly manual process because formats vary, fraud is a risk, and edge cases abound. The promising part is that if we automate data extraction from these documents, we should cover the most amount of applicants. But, however, this process must be secure and compliant because we're dealing with sensitive information, including PII. And also, it requires highest quality standards. Let's talk about types of documents that we can deal with. First, W-2s. They are year-end truths for wages and taxes, and they are really stable, but late. We'll use them as reconciliation anchors later. However, we have different layouts. However, all the boxes have documented labels by the IRS, so they are in these terms pretty stable. On the other hand, we have paystubs. They are more common. They carry salary details like cadence, earnings, deductions, year-to-dates, but they vary wildly. And this makes data extraction a challenge and quality checks a need. This is a common information that you can find on most of the pay stubs, like information about employer, employee, pay period, pay date, gross, net pay, itemized earnings, and so on. We will return to this example in a couple slides. And here you can find couple sample pay stubs that you can freely find online as an examples of how they look and how to read them on some universities, and there are generators of pay stubs as well. This is a really hot topic when somebody tries to fake their income. I want to say that even here you can see that their formats really vary. There are different labels for the same things, and structure is kind of different, and levels of details also different. So without any delay, let's discuss how to build processing for these types of documents. Our system works in stages: ingest, extract, normalize, validate, reconcile, scoring, QA, and feedback. Think of it as a pipeline where quality checks improve parsers over time. While the first part is already challenging in itself, today we'll focus on data quality part. Let's take a brief look on data extraction from these documents. First, we need to define a schema of data that we want to extract, and we use this throughout this talk. Since pay stubs are more common, more challenging, I will focus on them, but the same stuff applies to W-2s. So we want to extract company name, company address if available, pay date, pay periods, earnings, deductions, gross, net pay, and year-to-dates. For extraction, we use whatever reliably works for the documents that we deal with. Writing manual parsers when text layer is available in PDFs, with fallback on OCR, deep learning, and language models. In this example, we extracted some data from the sample paystub we saw earlier. For now, as you can see, data is not normalized yet. Dates are like in US format, money is in the string format. So during normalization, we clean data types like money, dates, identifiers, and do entity resolutions such as addresses, employer names. This turns raw strings into structured and comparable data. But since we are dealing with sensitive information, PI must be handled carefully. We need to verify that all the documents submitted are actually have the same names, because otherwise we need to fail initial validation. There are like messy documents from different persons, and this is a red flag. Also, everything should be redacted before processing, even for sending to LLMs, as we already discussed today. We can use tools like Presidio for regular expression-based and NLP-based detection of personal information and reduction. So, the core, the data quality layer. Let's define our model. Paystubs, W-2s, and provided bank history depict income of a person from different angles. So this gives us cross-referencing opportunity between them. Also, most of them have redundant information, so we can do self-validation of extracted data. And all these checks consolidate into a risk score that drives our decision process, whether to accept or reject these documents. This is where errors will surface. We start with tamper signals. Here are just a few signals that indicate files that may have been forged. None of them alone is a verdict, but together they usually pushes cases into review rather than to reject. But this is a completely different topic. We'll continue without it today. Next, my favorite part, validations on arithmetics in individual paychecks. Earnings must sum to gross, obviously, but there also could be an imputed income that should be subtracted from the gross. Taxes and deductions must breach gross and net, and all the same rules applies to year-to-date values as well. In this example, everything reconciles on line level. You can see that earnings and deductions, their sums match with parsed totals, so all of our checks passed. But in this example, we identified differences, like $1,622 for earnings versus sum versus gross year-to-date, $30 for gross net difference versus deductions, and $493 for the last one. This is a red light. Review is required. Next, we validate that year-to-date values roll forward in consecutive pay stubs. It must be non-decreasing, except at year boundaries or for corrections, obviously, and this rule applies to gross pay, net pay, earnings, and deductions. So, example, first check is passed, everything is correct, even at year boundary we detected that everything matches. But in the second example, our expected year-to-date is 800 less than we parsed gross year-to-date. It fails our check, and review may be required because it might be not a problem of our extraction, but problem in initial documents. Now let's talk about reconciliation, where we cross-check data from different document types. In this case, it's W-2s, our year-end anchors, and pay stubs are our monthly slices. To make them work together, we need to identify pay cadence, which can be derived from pay periods and pay dates. Or sometimes it can actually be parsed from pay stubs directly. We also need to account for pay increases, but this is kind of like tricky topic, which we won't cover today. So we compare average monthly wages from W-2s and pay stubs, average per check wages and taxes versus averages that we can get from W-2s. So another example, here we have past taxes checks, but failed. We have differences in wages, and it should trigger a review, but most of the reconciliation checks will have differences, so allow normal variance. Next, bank accounts. If available, ACH descriptors should match with the employer name, deposit should be close to net pay, and we need to ensure that deposit cadence aligns with pay schedule that we detected, but permit holiday and weekend shifts. These cross-source reconciliations allow us to identify any mismatches in the different angles on the same data. And finally, each check results in a pass, fail, or skip value that have its own severity. We calculate max severity as sum of all severities and past value as sum of severities for past checks. This gives us our risk score, where we apply our decision thresholds, whether to apply, review, or reject extracted data. This is how we surface all the errors. In this example, we passed our auto-accept threshold, but we also noted that there are differences in some of the checks. It can be used by our clients for their pipeline, but it's not like a red flag in this case, because reconciliation checks might fail because of the differences. But having risk score allows us to flag problematic documents early in the process and ensure that we provide verified and consistent data to our clients. This is how we build trust. So we talked a lot about LLMs today, but let's talk why without LLMs, how they can improve our quality even further. They can help in at least 3 ways: as assistive validators, as fallback parsers, as feedback sources to our flow. But they must stay within guardrails. As we discussed, PI is a sensitive topic, so before sending any data, we need to scrap PI. We need to require site to source so we can verify that data that they provided us is not hallucinated. And we should never override our deterministic checks. And before using LLMs as a default way of parser, you need to consider cost, because it might be cheaper to write parsers by hand or with LLM itself. Hallucinations, it's a pretty important topic when we talk about numbers, and also privacy choices, like local or hosted LLMs should be on your radar. So yeah. And one of the main, in my opinion, use cases for data quality could be detection of regression in our primary parsers. In this case, we verify parsed data by our primary parser with LLM parsed data. But before doing this, we need to normalize LLM parsed data using the same normalizers and validators, apply the same risk score, so we can build initial trust in the data that we compare. This way, we can identify differences and trust these differences. But remember, LLMs can do math, so they can fabricate consistent totals that don't appear on the documents actually. But they are really good at parsing PDFs. Today, we talked a lot about ChatGPT, Grok, but I never heard Claude. This is Claude Sonnet from this simple prompt parsed the sample paystub that we saw previously. Actually, the previous example that I showed you, I cheated. I used the same example. I didn't parse it by myself. So yeah, we discussed how to process individual applicants' documents, but we also need to look at bigger trends. Let's talk about metrics. To measure quality, we need to look at fill rates. So how many of expected fields extracted across the board? Data consistency. How many checks failed across the board or passed? Also system health. Our risk score distribution. You can actually have a health tiers for at a glance view, like is your system healthy? You have issues in different employers, or an outage and it requires immediate response. For operational KPIs, we can use false accept, false reject rates, review rate, and incident rate. Metrics makes your quality measurable and improvable. So let's talk about how to build a feedback for your system to persist the same level of quality over time. Operationally, you need observability, dashboards, alerts on quality drops, and log of incidents. You should be transparent with your clients when you identify a serious decline in your quality. This is important. to build trust. And also, as a good practice, you should review long-term trends in your own metrics. Finally, we should do a risk-based QA sampling, including regular automated reviews by LLMs and human spot checks. The latter can be as simple as a spreadsheet. And in the end, QA findings should be feedback to parsers to close the loop. This keeps system healthy over time. And remember to gather golden set of anonymized PDFs as a basis for your predictable parsers quality, including LLM-based parsers. So, to sum up, data quality is not a single step. It's a layered framework, normalizers, deterministic checks, assistive LLMs, and operational metrics working together. This way, income verification becomes a reliable, trustworthy, and scalable process. Thank you. Happy to take any questions.
Yep.
I'm actually curious about how you come up with the rules and the checks, because I'm assuming that there's probably a diminishing return at some point on the number of checks that you're putting in, and some checks probably give you a higher quality result. So just how do you use the least amount and get the best output?
Yeah, so really good question. Obviously, some of the checks you can, when you see paystub, it's obviously, as a human, you see that there should be some, corresponding. But a funny fact, we saw a lot of cases when paystub, mathematics behind the paystubs is actually not making sense. This is where we need to drop, actually, faulty values. So some of them just common sense. Some of them is just experience when we see trends in the data that we saw across the board. And we're just building up this knowledge. About the least amount of checks, this is just on a day-to-day basis. We're trying to find the sweet spot, and we still didn't find it yet. So this threshold that I showed is completely out of my head. It's not something we're using in production. But yeah, just experimenting and working with data. Yeah.
And a question from Slido. How do you handle data parsing from all the different sources? And would your AI workflow reject partial content so you could maintain full confidence?
Yeah, so obviously if we cannot be sure that we extracted all the data is obviously a red flag. We need to signal our clients that something is off and maybe manual review required. If it's on client side, if we can handle it inside, we obviously will handle it inside. So for different sources like photos, before we used different hosted OCRs with deep learning, but recently hosted LLM choices gives us much more robust solutions. So even a photograph of a paycheck is actually parsed pretty well. Our checks gives us trust in what we parsed actually with LLMs as well.
So what kind of improvement have you seen moving from the OCR solutions to LLMs?
Less garbage, actually. There are a lot of problems when, for example, you have text layer, but for some reason, payroll provider decided to put, or even employer decided to put image of their company name instead of actual name, and so you cannot relate it to your known employer database. And this is where OCRs completely fails.
Makes sense. Any other questions? We have one over there.
You mentioned you report to your client about your model success rates or your metrics. Do you build those into your contracts, and do you report on that? And what is your reception when you give them that data? So I didn't make any contracts. Unfortunately, I don't know the legal part of it. But yeah, we provide full and honest view on our current performance across coverage. So these employers, for example, can lose some of the fields more often compared to others. For example, this is a really weird case, but in some cases there is no company name on paystubs. So we cannot relate it directly and show that this is verification that this person works in this company.
Yeah, and incidents is something when something completely goes off. But overall coverage that I showed, I think here, yeah, some of this information is actually visible to our clients as well.
We do optical character recognition and we do some computer vision stuff, and we've debated back and forth about whether to expose the metrics for performance, because it's this belief that it should be 100%. Mm-hmm. What are you doing? It should be 100%. So we're in a different industry and everything, but I'm curious because we're on the front end of trying to think about that, and do we expose these metrics? And so I'm definitely curious to see that you do. Yeah, so in our case, this is a decision point for our clients. So whether they will receive information that is critical to their process, for example, for a lender. If lender can't know how much a human make, he cannot use our solution. Why they need, for example, they have a really significant amount of employees from specific employer, and we cannot provide them income from this. Why he will go to us like this? Makes sense. Thank you.
Great. I think we'll wrap up there. Thanks very much.
So, thank you.